All right, kia ora. It has just occurred to me that it is Thursday and I have not posted a walkthrough of how to answer my CPR quizzes for this week. So I'll make that and add that to the Google site right now. Unfortunately, I am on home isolation, so I can't print out any of these documents because I don't have a printer. So a lot of it might be me just talking to the doc or writing some notes down, or typing up some notes, I should say. But there is going to be a little bit on the document camera too. All right. So for CPR quiz number 2, I've given you guys a question on identification and using those techniques. Let me just zoom up. It's kind of small. All right. This one's been a mix and match. I've taken some of this question from the ESA and I've taken other bits from an exam. I really, really like the ESA question because it really shows you. Sorry, my partner's talking. Just close this door. All right, hopefully that cuts down the noise. All right, cool. The NCA question here, or not NCA question, the ESA question here on identifying compounds, I really, really like. The reason why is because it is very similar to what you're going to potentially get on the exam, which is we give you a molecule, and based off of the hints we give you, we need you to figure out what the compound is. Let me switch to the document camera because I think it's a lot easier for you to see the process if I do that on paper. For that document camera loads. And my normal pens are at school, unfortunately, so we're just going to use my glitter pens because that'll make it fun. All right, so the first thing to kind of keep in mind with this question is that they say that I have compound X. Let me just copy down some of that information. And they've given me the molecular formula for compound X, which is that C3H6O3. Cool. With that, it tells me that it reacts with dichromate, which is an oxidant. And with that oxidant, I then form compound Y. And with that compound Y, they give me a new formula, C3H4O3. So I've started writing that down on my piece of paper, just so you guys aren't thrown off when you see it when I switch over. I'm just copying down the information that's in that question. The other thing that they've stated in that is both X and Y react with sodium carbonate. And let's see what else it says. Sodium carbonate to make CO2 gas. Cool. All right. Identify compound X and Y and justify your answer. So let me just show you this. Now I'll process this for you because I think it's good to see these questions. Just because, like I said, one of the examples on the assessment is going to be, can you take formulas and hints and figure out what you then have. There was also some more stuff. Hold on. X can exist as enantiomers. I think that's the last thing. So I'll add that to my list. So every little thing you should be making a note of when you're trying to figure out what this is. Now you can do this obviously on scrap paper like I am on the test, or you can annotate the question directly. Normally I would just annotate the question directly, but I don't have a printout. But that's fine. Okay, so there's several different things I need you to do to help kind of gather the hints from this information. The first thing I always look at is I look at the molecular formulas to see what hints I can get from there. So the first thing I look for is the carbon hydrogen ratio. And the reason why I look at that carbon-hydrogen ratio, I hope the glitter pens aren't really bothering you too much, it's just my little bit of happiness for today. The carbon-hydrogen ratio is really important because that can tell us if there's double bonds. Now, with those double bonds, it could be C double bond C. It could also be C double bond O. So do keep that in mind. It's not going to give you an ability to differentiate which one you have. It just gives you a hint that there's some sort of double bond there. Really useful because I think in the last question last CPR, I've given you a section of a question which had a formula and then you wanted to figure out the isomers to them. And with that, there's actually a lot of different options and the hints there will help figure out which isomer you need to identify. So when I'm looking at this here, I see that I have 3 carbons and I have double the amount. So it's 1x to 2x and there's no plus 2 there. So what that tells me then is that there's 1 double bond. So that's kind of the first hint that I have there, that I have some double bond present. The other thing I want to look for is what other elements are there. So I see that there's oxygen there, and that oxygen, okay, I can start thinking about what potential function groups have oxygen there. Say, for example, I know alcohols have oxygen, because that's the OH. I know carboxylic acids have oxygen. That's that C double bond O and an OH. And I know my aldehydes and ketones, which has that C double bond O, carbonyls. So all that information kind of helps me get an idea of what's there. Since I have so many oxygens, I have 3, what that tells me is that I'm likely to have multiple functional groups. I know it's not just simply a carboxylic acid because then I would only see 2 oxygens. So the fact that I see 3 tells me that there's probably multiple. I'm running out of space. Groups. Okay, so that's kind of what I've gotten from the first hint of the question. And I personally don't like to jump all the way in and figure out, okay, what's my molecule then? I like to read the whole question, get all my hints, and then figure out my molecules. And the reason why is because some of this stuff can backtrack and help me confirm things. What it can also do is it can help confirm each other. And you'll see what I mean in a moment. So that's my first bit of information. The second bit of information here says that it reacts with an oxidant to form compound Y. So since this is reacting with dichromate, going from orange to green, what that tells me that has to be present is an alcohol. Because we know that the alcohols can oxidize. Oops, I can't spell groups. There we go. So alcohols must be at least one of those function groups there. Oh, I can see glitter on my page in my hand. That's why I use glitter pens, for fun. All right. Again, I want you to look at that molecular formula and see if there are hints there. So what I notice when I look at this is that my oxygen number hasn't changed. My carbon number hasn't changed. But I have lost 2 hydrogens. So I've gone from 1x ratio is 2x minus 2. So that works out because if I do 3 times 2, that equals 6 minus 2 equals 4, which is how many hydrogens I now have. So what that then tells me is if I'm losing 2 more hydrogens, I'm losing 2 more potential bonds. So now I have another double bond. So what this tells me in that molecule, which again verifies what we see here with the reacts with the compound Y, and that alcohol is being oxidized. If that alcohol is being oxidized, well, then I'm forming a carbonyl. I hope that makes sense with my thought process. So like I said, it's verifying each other, and that's confirming that alcohol has been converted into a carbonyl, because now I see an extra double bond there, and that's where my double bond is. One last hint from this question is that both X and Y react with sodium carbonate to make CO2 gas. So if you guys remember from, I want to say it must have been year 11, you talked about sodium carbonate, and you talked about how sodium carbonate is a base. And when you add it to an acid, it makes CO2. So since I see that CO2 is being produced, what that tells me is that both X and Y have a C double bond O functional group. So again, that all helps me kind of figure out what's going on. Cool. That idea, if I'm looking at this, has a carboxylic acid functional group and has an alcohol, well, that verifies what I was saying here about the multiple functional groups needing to be present because of those three oxygens. So you see how I was saying these hints will complement each other. So let's figure out compound X, because once I have compound X, I can easily figure out Y. Don't feel like you need to go in that order. Sometimes it might be easier to work with the product and work backwards. In this case, it just makes more sense for me to work forward. So back to compound X, I must have 3 carbons. It has to exist as enantiomers, so that information is important for me to note, because then I know that there must be a chiral carbon. So I should have basically a carbon on there with 4 different things, and that's, again, another way to verify I have the right answer. So first thing I know, there must be a carboxylic acids, and carboxylic acids can only exist if they are on carbon number 1. So that has taken care of some things. The other thing I could do is keep a tally of how many oxygens, hydrogens, and carbons I've used to make sure that I have the right formula and I haven't forgotten something. So 3 carbons have been used, 1 hydrogen, and my 2 oxygen. So what I have left over are the hydrogens and the oxygen. Now the main thing I want to put down right now is the oxygen, because the hydrogens are just fillers. So I know that there must be an alcohol present, because I've already confirmed that with the fact that this compound X will oxidize. And basically that alcohol can go on carbon number 1 or carbon number 2. I need to figure out which one it is. Now, this hint here about the chiral carbons helps me figure out which one it is. If I put the alcohol on carbon number 1, there would be no chiral carbon. And the reason why is because I would have 2 hydrogens on this carbon, excluding it from being a chiral. This one would have 2 hydrogens, excluding it from being chiral. And this one can't be chiral because of the double bonded oxygen. So the alcohol can exist on carbon number 1. It has to exist on carbon number 2. So with it existing on carbon number 2, I would need 1 hydrogen to fill it, and then I would have the methyl, and I would have, let me backtrack and actually finish the molecule. Okay. So I'm just keeping my tally going. Okay. So I have added 1, 2, 3, 4, 5 hydrogens. I've added that to my total, and that's 6, which matches what the formula says. I still have those 3 hydrogens, and adding that OH there means I've had another oxygen, so that's 3. So that matches the formula that I was given. With this alcohol being on carbon number 2, I do have a chiral carbon, because I noticed that the alcohol is my first group, the methyl is my second, the hydrogen is my third, and then the 4th thing attached to that carbon is the carboxylic acid little chain here. So that has 4 different things attached. That's my chiral carbon. So I have met the other hint there. So does this meet all the requirements? It will react with sodium carbonate. it will oxidize, and it does have a chiral carbon, and this matches the formula that I was given. So that has met all the requirements, and that's how I know I have the correct formula for that answer. Second bit now is really easy. So like I said, depending on the order that you write things in or do things in, it might be easy to go backwards. In this case, it's easier to go forward because all I need to do now is show the oxidized version of this compound. So that oxidized version just means that I have gotten rid of 2 hydrogens, which is going to be that one and that one, to form a carbonyl. And that is my ketone. Again, check the carbon, hydrogen, and oxygen numbers. 3 carbons, that doesn't change. 1, 2, 3 oxygens, that doesn't change. But the hydrogens are now 3 plus 1, 1, 2, 3, 4. And that's confirming that removal of the 2 hydrogens to form that double bond. And that's how I do the answer to that one. I really love those questions. They really get you to think, because you need to really actually understand all the content to be able to integrate this material in. The great thing about this question on the assessment is that it's a very easy excellence point. Usually you will be doing this and they will give you probably somewhere to be between 2 to 4, more likely 3 to 4, maybe even 5 different molecules to figure out. There's no explanation point to it. Usually it's just, can you identify those molecules? And if you can identify the molecules, it shows that you're able to integrate that information together and you should be able to get an excellence point. So usually with this, it's just a breakdown on how many you get right. So maybe you get 1 right, you get an achieved, you get 3 right, you get the merit, if you get all 4 right, you get the excellence. So like I said, this is a really easy excellence point because there isn't that explanation component to it that you see with thermal chemistry, for example. All right, cool. I know it wants you to justify your answer. I think the annotations kind of speak for themselves. All right, the next question here was just looking at techniques. So you're doing the alcohol to the aldehyde and the alcohol to the carboxylic acid and outlining why. And then there's also the distinguishing test between the ketones and aldehydes, which is some of the new material that we've covered. I won't go through in-depth answers because you guys have the marking schedule. And it doesn't require the same kind of explanation because I think it's more self-explanatory. In this case, with the molecular formula question, I feel like I do need to kind of show you how to go through it because it is a process. But anyway, when you're looking at this answer here, you can see how it breaks down to the achieve, merit, and excellence. The main thing I see that lets a lot of students down is that they forget to give equations. So do make sure to do that. If the question states equations or relevant equations showing any organic reactants and products involved, that's not an optional thing. It's very often in the excellence point that you need to have the equation there. And in this case, for the merit point, they were accepting 2 of the possibilities for it. So an equation would have helped you. But yeah, I can guarantee you they will not issue any excellence points if you don't have the equation down when they've asked for equations. So do keep that in mind. Anyway, I hope that helps. Do let me know if you have any questions. We will do more examples like this because it's a good way to kind of build your confidence with organic chemistry and really kind of revise. And it's also good preparation for the spec internal as well because spec is kind of similar to that kind of question. All right. That's all.